Hello, let's continue our Sudoku adventure with Lower Warden by Wuschel. So we have normal 6x6 Sudoku rules. That means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have this blue diagonal in the grid. That designates that this diagonal and just this diagonal, it also acts like a row, column, or box, and that we are placing the digits 1 to 6 exactly once each. Another way to put that is that the digits don't repeat. We also have killer cages in the grid. So let's use this as an example here. The killer cages are just these cells that are surrounded by dotted lines, and then there's a clue in the top left. So first of all, digits can't repeat in a cage. So normally Sudoku would absolutely allow us to put a 1 here and a 1 here, but because they share a cage, that's no longer allowed. Additionally, the digits in a cage sum to the value in the top left. So if we were to sum up the digits in these 4 cells, that would sum to 12. So one example would be maybe 1, 2, 3, 6. All right, so those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now, after I get a drink of water. All right, so there's a lot, in fact, all the cages are 12 in size, and almost all of them are 4 size 12s. So let's think about 12 and 4. So we could do 1, 2, 3, 6. Let's actually just write it out here. We could do 1, 2, 3, 6. Let's do it over here so it's not with the 4 here. 1, 2, 3, 6. All right, we're just doing the smallest numbers possible, and then we're adding a 6 to get to 12. We could also increase the 3 by 1 to do 1, 2, 4. Of course, I did it where it sees the 4 anyway. 1, 2, 4. That adds to 7. So how do we then get to how do we get to 12 from 7? We add a 5. Right, and so these are going to be the only 2 ways to add to 12, because if you think about it, if I increase that 2 by 1 now, because I can't increase the 4 by 1, if I increase the 2 by 1, I end up with 1, 3, 4, 5 as the minimum, and that's going to be 13. So these are the only 2 ways to add to 12. And that's probably going to be important, especially because there's a 4 here. So we could just get this digit immediately using outie. So you can think about it 2 ways. One is, well, this rules out 1, 2, 4, 5. So this is 1, 2, 3, 6. That makes this a 5. Or if you don't want to think about it that way, you can use outies. So we know that this box sums to 21 because it has the digits 1 to 6 in it, and 1 to 6 adds to 21. Well, if we subtract 16 from that, these are going to add to 12 based on the rules, and this is a 4. So if we subtract 16 from that, 21 minus 16 is 5. So either way, we're placing a 5 here. And I am actually going to put 1, 2, 3, 6 here. And I'm going to color that to designate that this is the purple flavor of our 12 sums. And so now if you look at this cage and this cage, you can see what's happening here is, can I make this cage purple? And the answer is no, because there's only 4 purple digits and we need 5 of them in this row. So this can't be the purple flavor. This is the green flavor, and we know what that flavor is. It's 1, 2, 4, 5. So we can clean that up a little bit. And then this one as well cannot make it purple, because if I made it purple, I'd again have 5 purples in the column. So we're going to make that green. It's a 1, 2, 4, 5. And then this one here can't be green because there'd be too many greens in this column. So this is the purple one. This is 1, 2, 3, 6. So this is going to be our 4, 5 pair. This 4 sees the 5 by diagonal. So we can clean that up. Okay. So the other thing we've done is we put a 5 in here. And so that means this is a 1, 2, 4, 5. So we can put 1, 2, 4 in here. And the 4 is on the diagonal, so it cleans up both of those. So this is a 4. Nice, this is going smoothly. This is a 1, 2 pair in this cage, so we can actually get the 5 and the 4 here now. Okay, this is a 1, 2 pair. Oh, I don't know what I just did. Hope I didn't show anything weird. This is a 1, 2 pair, and sorry, I got super distracted by whatever just popped up. This is a 1, 2 pair, right? Because it's on a diagonal, so they can't repeat. So first of all, these can't be 1, 2. So let's do that first. But most importantly, think about which cells see this 1, 2, right? It's all of these cells. This is going to happen a lot in diagonal puzzles. None of these cells can be a 1 or a 2, because if they were, they would remove that 1 or 2 from both of these cells, and we know one of them has a 1 and one of them has a 2. So this cell can't be a 1 or 2, and it can't be 4 or 5 either. So this is from 3, 6. And these cells can't be 1 or 2. So this is not 1 or 2. These aren't 1 or 2, so these are from 3, 4, 5, 6. We can clean that up a little bit. Okay. So what did we get from all that? This cell here needs to go in this row. I guess it could be a 1 or 2 though. All right, what are we doing here? Is it this 12 cage? Oh, it's these 5s are helpful. These 5s look down. So this this box needs a 5. And that's going to make this a 3, 6 pair. That's going to look up, making this a 1, 2 pair. I don't think I need these colors anymore. In fact, I don't think I ever needed the colors. It was mostly for demonstration purposes. So, let's see. This is going to be from 1, 2, 3, 6. Oh, both of these are. I'm missing something obvious, I'm sure. Okay, maybe we think about this 1, 2, 3, 6 down here. We're gonna have 1 of 1, 2 and 1 of 3, 6 in here, right? Because the other 1, 2 is here and the other 3, 6 is here. So can I include a 3, right? If I include a 3, then the highest I can do is 3 and 2. Okay, so if the highest I can do is 3 and 2, that's 5. This would have to be a 7. So I can't actually include a 3 in here. So if this is the other 3, 6, that doesn't go here, it has to be the 3. So that's a 3. That means that one of these is a 6, so that's not a 6. So this is either 6 plus 1, that's 7. We do 7 plus 4, or 6 plus 2 is 8. We do 8 plus 3. No, 8 plus 3 doesn't work. Sorry, did I do that wrong? No, 7 is just not big enough. I did that wrong. We need to do 7 plus 5, and we can't put a 5 here. Okay, so this is 2, 6. This is the 1, this is the 2. Nice, okay, that's a 1. These are not 1s. That's not 1, 3, that's not a 1. Okay. And so 2 plus 6 is 8, so we need this to be a 4. Let's do the math correctly. That resolves all of these things. Let's do the diagonal before we forget. And then I think our red marks might finish this puzzle. Close. Okay, and then here we need a 1 and we need a 6. And then here we need 3, 5, and 6. The 3 goes here. This is the 6, this is the 5. Nice. Cool puzzle, Wuschel. Yeah, I like how the 12 cages interacted. That was a neat idea. How we had to have these be one flavor and then these were the other two. These two were the same flavor and then this was the other flavor again. Yeah, and nice opener here with this given 4, just immediately disambiguating which was extremely helpful. So thank you for that as well. Very kind setting. And of course, if you enjoyed this, then why not leave a like, subscribe, and a kind comment below.